Okay, this is a study guide video that I put together for, I believe, Mackenzie and Fiona for Math 1, sections 5.1 through 5.6. These were some of the problems I remember most working with you ladies, and then a couple problems out of the packet. But here we go. I'm thinking you're going to need to know how to graph using just the X and Y intercepts. And if you remember, wherever your graph crosses this x-axis right here, always for the x-intercept, you have not x is 0, you have y is 0 for the x-intercept, wherever it's crossing over the x-axis. For the y-intercept, it's the opposite. It's the x-coordinate. That's always 0. So really what you're doing for these, you're pretty much plugging in a 0 for a y, which makes this go away, and you're solving that for x. So when that y piece is gone, when I plug in 0 for y and all I'm left with is 2x plus 12, I'll divide by 2 and that will give me 6, because remember right there you have 2x plus 3 times 0 equals 12. That will go away and you're just solving for 2x right there. Divide by 2 and that gives me the x intercept coordinate is 6. The opposite of the y-intercept, you're plugging in x is 0. So this is the one that's going to go away when you plug in 0 for the x-intercept. Or remember, this one, you're plugging in 0 for x, so that's going to go away, and you're solving for just the y one. So 3y equals 12. Divide that by 3. That gives you the y coordinate. The y coordinate is 4. Those are my y-intercepts. So 6, 0 would be right here. Always where it crosses the x-axis, x is 0, and my y-intercept would be at 0, 4. I believe you're going to be doing a problem like that, graphing using just the x and y intercepts, plugging in 0 for x, plugging in 0 for y, knowing that for the x-intercept, y is always 0. For the y-intercept, x is 0. So I'd like you to try this one right here. For the x-intercept, plug in y is 0. Y is always 0 for the x-intercept. Plug in 0 right here and solve for x. For the y-intercept, I want you to plug in not y is 0 for the y-intercept. I want you to plug in x is 0 and try that. Again, knowing that when I plug in y is 0, I'm pretty much just solving that for x, divided it by 4. When I plug in x is 0, I'm pretty much dividing both sides by -5. So try that one. All right, I'm thinking if you did this one right, this one 20 divided by is 5, 20 divided by 4, and then 20 divided by -5 gives me -4 for the y-intercept, I believe. So again, when y is 0, x is 5. When x is 0, y is -4. So this one, 5, 0, and 0, -4. Those are my two coordinates right there. Graphing using just the x-intercept where it's crossing the x-axis, and the y-intercept where it's crossing the y-axis. All right, thanks for listening. Keep on going. Next problems were these expressions where they had you write in expressions and use it. So $14 for a pair for shirts, $23 for pants. I had one of my ladies write the equation, the y, which is cost. We'll just use y as cost. Cost comes from $14 for every shirt plus that $23 for every pair of pants. So that's going to be my general expression. To find the cost, it's just 14 times how many shirts plus 23 times how many pants. To find the cost for 6 shirts and 10 pants, I'm just plugging those numbers in. So where 14 is, I'm going to plug in the number of shirts right there. And where pants is, I'm going to plug in the number of pants, and then just do the math. Calculate the cost after buying 6 pairs of shirts for 14 bucks and pairs of pants, 10 of them for 23 bucks. That gives me 14 times 6. My cost is going to be 84 for the shirts plus 230 for the pants. If I add that up, that gives me a total cost, I believe, of about $314 I'm spending buying that much. All right, so I'm going to have you try one on your own. This is 2.5 for shirts, 11.5 for pants. Try to calculate, write an expression, and calculate the cost for 7 and 12. Try that. All right, I believe if you did this one right, I'm looking at 2.5 shirts plus 11.5 pants. And when I plug those numbers in, when I plugged in 2.5 times 7 and I plugged in 11.5 times 5, I believe that gave me 41. Let's just double check. 2.5 times 7 plus 11.5 times, 12 pair of pants. Glad I checked that. Don't plug in 5 right there. Buying 12 pairs of pants times 12. That gives me, there we go, $155.05. That means 50 cents. That's not 5 cents. That's 50 cents right there. How much I'm spending. All right. Next. Hopefully I'm not making mistakes. Hopefully. I'm human, but here we go. This one. Graphing inequalities. Knowing that this 3 tells you where on the y-axis to put your first point on 3. That number in front of x, the way I teach it, any whole number put over 1, the way I teach it is that slope. I always do my run left to right, which just leaves my rise as either going up or down. So going over to the right 1, then I'm going down 2. So right 1, down 2, right 1, down 2, right 1, down 2. Always be able to stair step the opposite way, left 1, up 2. Draw my line, but then remember, you gotta be careful. This inequality means it's gonna be a dotted line. I do not have this. If this line was there, it would be solid, but that's not. So this line through those is definitely dotted. Let me try to draw a better line here. Draw your line through them. Know that this line is going to be dotted, a dotted boundary. I could use my computer to fix that, make that dotted. Dotted boundary, which means I cannot use any points along that boundary. And then that inequality tells me how to shade it. This, if you translate it, is y is less than. Less than to me is always below the line. I don't care how it's drawn. I don't care how a line drawn. Below is underneath the line. So this one, I don't care how the line's drawn. It is less than. I'm going to be making that dotted. So let's try to make that dotted. Sorry about that. There we go. And then that dotted zone is below. I shade below. Every single point in this shaded zone is a solution to this system or to this inequality. It doesn't give you an exact 2 equal numbers, but again, any coordinate in this zone, if I plug in for x and y into that equation underneath, is going to give me a true statement. If I plug in 0 for y and keep that inequality this way and plug in 0 for x, so that would be -2, and plugging in 0 right here, and then adding that 3 should give me a true statement. Is 0 less than 3? That is true. 0 is less than 3. Any points along this line will not work. If I was to plug in 0, 3 for x and y, that would give me 3 equals negative 2 times 0. Oops, I'm sorry, not equal. That would give me 3 less than negative 2 times 0 plus 3. 3 less than 3. That is not true. That's why you can't pick points on a dotted line. If I had my inequality less than or equal to, that means yes, I can choose points on that line. But again, a dotted line is there for a reason. Those coordinates, you cannot choose points on the dotted line. All right, here we go. Next one. Start at negative 2. This one has a slope of right 2, up 1, right 2, up 1, right 2, up 1. Stair step the opposite way. Down 1, left 2, down 1, left 2. This arrow shows me, or this inequality, it's going to be a solid line. That means any coordinate along that line for this inequality graph will work. It will give you a true statement. So I'm going to make this line and leave it solid. Now this inequality is saying y is more than. That's what that means, the way it's pointing. Y is more than. To me, more than is always above the line, no matter how it's drawn above. I don't care how your line's drawn. Above is up here. I don't care how your line's drawn. That's above. So for this one, the shaded zone goes above, goes up here with that solid line. Any point along that line for this one will work, because if you plug in a coordinate for x and y into one of these, let me show you what happens. You'll plug in 0 for y, and I'll have greater than or equal to 1/2 times 0 for that x number I'm sorry, that negative 2 number I'm getting for x right there, minus that 2. That gives me 0 greater than or equal to, let's see, what did I do right there? Oh, whoops. In that check, again, let me show you that check again the right way. Plugging in negative 2 for y, sorry about that, gives me more than or equal to 1/2 times 0 minus 2. That gives me negative 2 greater than or equal to negative 2. It's not greater than, but because of that, that makes this true. That means points on a solid line you can check, because they'll have that little equal line over there to make them true. All right, next kind of problem I saw were these systems. Here we go. This one, you need to solve both for y. So if I solve this one in red in one step to get that y by itself, I have y equals negative 2x plus 5. To solve a system, graph both lines and see where they intersect. So this blue one starting at 2, over 1, up 1, over 1, up 1, over 1, up 1, stair step the opposite way. If I graph my red one starting at 5, this one is right 1, down 2, right 1, down 2. That other one was over 1, up 1. So you could see right 1, down 2 already intersecting. Right 1, down 2, right 1, down 2. A one solution system. There is my line, and where those intersect, that is your coordinate. That is your solution point. That is for x and y. 1 is x, 3 is y. That is my solution. If I wanted to check it, I'm plugging in 3 for y and 1 for x, and I got to do it for both for it to show that it's really a solution if I wanted to check it. You need to know how to get that same answer substituting. Remember, when you solve one of them, that tells you where in the other equation to substitute. This tells you what you're taking and putting right here in that y spot. So when I substitute that second equation, I still have 2x there, but where that y used to be, that red y, I don't have that anymore. Now I'm replacing that with x plus 2, what represented y from the other equation. Then I still have 5 right there. Gonna have you combine like terms, gives me 3x plus 2 equals 5. Take away 2, that'll give me 3x equals 3. Divide by 3, and there it is. There's half my answer. There's the 1, just like that graph showed. There's 1. But remember, substitution, you got to then show the work to plug this back in to any of them. I'll probably use this first one. You got to plug that back in and show the work that solves for y. Some people forget to do this. So here's y. I'm going to plug in 1 for x into that top equation plus 2. That gives me when x is 1, y is 3. There it is. Support your work. Plug it in. Elimination, a little bit different. Elimination, I need to get it in what's called standard form, everything together. So I'm going to take that x away one step, and I'm going to rewrite it. Negative x plus y equals 2. And the other equation is 2x plus y equals 5. It looks like if I took one of my rows and times by probably 2, that's probably what I'm going to do, times this top row by 2 will make this become 2x negative to cancel that one. That's why I'm timesing that top row by 2. That's my adjustment. I'm going to multiply everything by 2. I'm going to distribute that 2 and then rewrite both. Here I go. Here's that top equation. After distributing that 2, that gives me negative 2x plus 2y equals 4. That bottom equation is the same. 2x plus y equals 5. Now I add them up, and hopefully one of my variables eliminates. See ya, because they're opposites. 2y and 1y gives me 3y. 4 plus 9 gives me 9. Divide by 3, and there it is. There's your y number, the same as all these other ones, because these are the same equations. That's 3. Make sure you put that in the right spot for y. And then for this, you do got to support your work in my class and show me how you get x. I know x is 1, but support your work. You could plug that in to any of these. You could plug it into the rearranged one. You could plug it into the original. I'm going to probably, let's see, use that original one up there probably. So here I go. So I got 3 equals x plus 2, and then in one simple step to support my work to show what x is, take away 2. That gives me x is 1. That supports my work. That's the coordinate 1, 3. All 3 methods give you 1, 3. All right, almost done. The last thing I saw was just looking through your packet, looking at these. These again, they're having you check solutions where this is x and the other number is y. They're having you plug those in the right place. The only way you're going to get these wrong is if you plug in 2 for y or something. So here I go. I got to take this and plug it into all of them just to see if that point is a solution. I got to check both. So here I go. Here's that first one. I'm going to plug in 5 for y. I still got 2. I'm going to plug in negative 2 for that x right there, minus 3. If this doesn't work, I'm not even going to check that next one there because I know, there's no way that is 2 equal numbers. No way. So not even going to check the next one. If I check that other one, again, that's just kind of a waste of time. It's got to work in both. So if I'm plugging in one and it right away is not working, don't even plug in the other one. Let's try the second one. Plug in 1 for y equal 2. Plug in 2 for x minus 3. That gives me 1 equals 4 minus 3. 1 equals 1. That one works, but before I could say that point B is a point, I got to check it in the second equation as well. So here I go. That second one, I plug in that same 1 for y. I got equal, negative, and then I'm going to put that x number in there, and that's going to make that x number negative plus 3. And I can see that one does work. That point worked for both. So that is a solution point. That's how you check if a point's a solution. Both have to work. You got to be able to plug that into X and Y into both to make it work. If it doesn't work in just one of them, right away it's not a solution. It has to work in both. All right, here we go. Last one. Solving and putting in slope intercept form, which is the most important in my eyes, and then maybe a couple practice standard form, which is getting it ready for elimination, everything ready. So here you go. That first one, number one, I'm going to take away 7x on both sides. I'm going to write that down here because that's just kind of nonsense trying to show that work up there. So here's number one shown a little bit better. So to solve for y, I'm going to first always get rid of the x term. Always, because you're trying to get that y by itself. Don't forget to bring down negative 14 with this y. I'm always going to write it in slope intercept form with that x number first and that plane number second. And then I'm going to divide everything by negative 14. Everything by negative 14. That will make these cancel away and leave me just plain old y. Negative 7 over negative 14 reduces to positive 1/2 x. And then I don't know what 56 divided by 14, use my calculator. That gives me plus 4 because of those two negatives. So there's that first equation solved for y. If I do that for the second one here, second one, negative 8x minus 2y equals 6. I'm going to first add x to both sides. Add 8x, add 8x. Bring down the negative 2 with the y. Write this as 8x plus 6. And then right there, don't add 2. Divide everything by negative 2. That will make those go away. That gives me y equals negative 4x minus 3 when I simplify those two pieces right there. So again, knowing how to take an equation in standard form or any other form and solve it for y, get that y all solved for. All right, the last problems here are writing in standard form. So here we go. Number 4, just a couple standard form ones. I'm going to get this x on this side here. And that's going to give me negative 7x plus y equals negative 3. I do believe we don't want this first term to be negative. So if I times everything by negative 1, if I distribute a negative 1 all the way through, that will be 7x minus y equals positive 3, I believe. Kind of that's what they want you to do. They don't want that first term to be negative technically. So if I do the others, take away 2x, gives me negative 2x plus y equals 9. If I do that times by negative 1 trick all the way through, I believe I get the answer 2x. If I could write that better. 2x minus y equals negative 9, I believe. For this one right here, all I'm doing is adding 4x. Adding 4x gives me 4x plus y, and then I'm okay with that being negative 11. There we go. I got positive 4x. This guy right here, take away 1/2 x, gives me negative 1/2 x plus y equals 8. To make this negative 1/2 go away, I'm going to times by negative 2. That will give me negative 2. That'll give me positive 2 over 2, which really makes that 1. So here I go. If I distribute a negative 2 through there, ooh, tricky. That's going to make this positive x minus 2y equals negative 16. Again, I know those fractions are weird. When I times -2 times -1/2, remember by rule, times them straight across, that will give me -2 over -2. That's where I get 1 right there. All right, hopefully this video helps a little bit. Good luck on your test, ladies.